Okay, I want to take a moment and talk about some of the hardware that goes into PLCs here. And we have I/O on PLCs, and generally you're going to have more inputs than you have outputs, and that's because we program PLCs to react to the state of inputs. So generally we're not going to just say if this is on, if this input is on, turn this output on. We're generally going to say if this input's on and maybe this input's on, and maybe if this input's not on, then turn on an output. So typically we're monitoring more inputs than we are acting upon outputs. And so on this type of package controller that you see on the left-hand side, everyone I've ever seen has always had generally almost twice as many, at least 1.5 times as the amount of inputs as there are outputs. Now, when you get into rack systems like you see here on the right, you can pick your I/O, and a lot of times they'll be matched 1-to-1 simply because if you buy a 16-bit input card, you're going to have an output card, and they oftentimes come in 16-bit outputs as well. And so it's not that you won't always will have more, but especially on the package controllers you will. And of course your inputs accept signals. They're looking at something, and convert them into the signals that can be used by the controller. So bottom line, we're looking at a switch or a sensor or something out there that's can either be set by the operator or set by something coming down a conveyor or outputted from another piece of equipment. And output interface modules convert things from the controller or CPU into external signals to control the process. And if you look here, you'll see already the processor module, and this addressing is going to be very important to you, is in slot 0, this is in slot 1, this is slot 2, and so forth. And that's just because just like you live somewhere in a neighborhood or maybe out in the country, but still on this road you have a unique address. These bits that this stuff ties to has to have its unique address, and that's where we get that from. The closer we can get this stuff minimizes the amount of wiring. I'm not going to read every one of these slides. I'll let you read, but I want to hit some of the high points. And you notice here we have 2 different racks, so we can have more than one rack, and we have some communication that's going on in between the two, so we can have a local rack and a remote rack. So this is when it gets into the addressing. We're generally going to have a rack number and what type, whether it's an input or an output, what slot number it's in, and what bit. So just like you might live on 124 West 2nd, well, the street is West 2nd, your address is 124, and this address of this bit tells us that it's an input, it's in slot 2, and it's hooked to terminal 0 of that particular I/O device. And when you look at this is a general rack system here, and you can read all this. I'll let you get there on your own, but we're going to have a different numbers here. So like an output in slot 4, terminal 15. So if this were really this right here, this would be slot 0, slot 1, slot 2, slot 3, slot 4, and it would be tied to terminal 15. And you get the idea, input slot 3, terminal 8. So 1, 2, 3, there it is. And I don't think these cards actually match down here, but you get the idea. So we know when we look at a rack, if we've got something that tells us this is on output 6, we count 1, 2, 3, 4, 5, 6, and we know it's dealing with this card and this bit. So this addressing is very important to us, and that's how we can tell. And this is showing more about the inputs, and generally we start with bit 0, so 0, 1, 2, 3, 4, so forth and so on. So on an input card, if this were in slot 2, it would be input. Well, it's actually slot 1, so I'll use slot 1. It would be input, slot 1, bit 0. Input, slot 1, bit 1. And that's how the processor knows what's tied to these screws, this hardware in the real world. Same with the outputs. This is output slot 3, bit 0, output slot 3, bit 1, bit 2, bit 3, so forth and so on. You get the idea. Now, there's analog modules, and you'll get to those later, but discrete modules are what see only zeros and ones. Analog modules deal with values that are greater than 1, basically, and convert them into a digital format. And now Allen Bradley has gotten into what we call tag-based addressing. Once we assign an alias, rather than having to remember that, hey, this switch is tied to, the start switch is tied to input 3, bit 12. Every time we go to create programming with input 3, bit 12, we've got to remember that address exclusively. But we can tie that address to a tag, and that tag could just be called start switch. And once we do that, then we can call it by what we know its name is in functional wise in the real world. And that's what these tags do. They allow us to not have to remember this lengthy address we have here. And so you can have some PC-based stuff that simulates the function of PLC on a PC. In the industrial world, you're generally going to deal with manufacturers like Allen Bradley, Siemens, ABB, and there's several other companies out there that make these PLCs. And they do make cards that have both inputs and outputs mixed in with them. And the type of package we use is going to depend on what we need. And this is just showing you one of the Allen Bradley cards. This is one of the SLC modules, it looks like. And we can buy these and purchase these and configure a rack the way we want it. Because you can imagine if you're building a fairly complex system that needs 60-something inputs and 40-something outputs, you would have to have something either very robust, and they would have to charge you an arm and a leg, so to speak, for this specific type thing, or you would have these configurable cards that you can purchase and set up your own way. And if you throw in analog modules on the input and output side, that's just going to make it more customizable for your own personal needs. And most of these have plug-in wiring, and the reason for that, if you can imagine, if you've got 20, 30, 40 wires connected to a card and that card goes bad, you're going to have to down the line, take all those terminations off of the card that's bad and try to put them back in the same order on the new card. With this, you just pull the strip off, replace the card, and pop it back on in just a few seconds, or a couple of minutes anyway, you're back to running. I/O comes in all kinds of different flavors. You can get 8-bit, 16-bit, 32-bit, 64-bit. With some of the Allen Bradley, you can buy some add-on I/O called point modules, where you can get just 1 or 2 or 4 add-ons. So they come in all flavors and shapes and sizes. So discrete is either on or off. We talked about that. So when I push a button, I'm activating a signal through that button. Or if it's a stop button, I'm maybe stopping that signal. But that signal is either on or off. This switch is either on or off. This selector switch is either on or off. This limit switch is either closed or open. Same with these proxies. So we're taking these inputs, and this processor and package controller you see here is just looking at whether that's on or off. Is this device giving me a 1 or is it giving me a 0? And based on the programming, it's going to write either a 1 or a 0 that's an output, and those outputs are going to be connected to indicator lights, might be stack lights, maybe controlling a relay, maybe controlling a motor starter. That's up to you as you write the program. But we're looking at these inputs, we're writing a program and saying act upon these outputs based on these inputs. And again, I'm not going to read you every slide, but cards, inputs and output cards come in flavors of AC and DC, varying voltage levels of AC and DC. So if you've got something that is, you're interfacing 3 or 4 different machines that are using 3 or 4 different voltage levels, it's still not a problem. You can buy cards that will work with each of those. And now the modules themselves get their power in a rack system from the backplane, and this is a configurable backplane or a configurable rack. So I can buy the rack, it's got to have a power supply, it's got to have a processor, and then I can mix and match my I/O and do what I want here. And again, please be reading these slides. I'm just hitting the highlights. And this is just a block diagram of a discrete I/O, and here's an AC. And again, I'm not going to read you every one of these. I wanted to talk about the main stuff here. This is something to kind of talk about. Individual AC outputs are usually limited to 1 or 2 amps, so you're not going to cut on a 5 amp motor with an output card. You're going to have some kind of interface device, a relay or a contactor that will take care of that for you. So we use control relays along with these output cards to do just that. And again, discrete on or off, on or off, on or off. And they come in different ways, whether we're current sourcing or current syncing. So you want to match those as well. So analog inputs, again, I'm going to let you read these slides. They can take a varying signal from 0 to 20 milliamps, 4 to 20 milliamps, or 0 to 10 volts, and convert it into a digital signal that PLC can understand. The PLC is a computer, the processor part. It doesn't understand analog, but it understands that conversion from analog to digital, and that's what these cards do. And again, I'm going to let you read these. So we've got a temperature probe here, a sensor transducer, and a transmitter. So basically we're bringing in 2 wires that's varying between 0 and 10 volts, and this card can accept it and interpret that level into something meaningful to the processor and to you as the programmer. The processor is going to see it solely as a 0 to 10 volt input until you write the code that scales this 0 to 10 volt signal into something that you understand. So maybe you've got a process that runs from minus 50 degrees to plus 200 degrees. You can scale that to match the 0 to 10 volt signal. Again, I'll let you read each of these. This is talking about the analog systems, and this is talking about the scaling, the very thing we talked about. Special I/O modules, high-speed counters, thumb wheels, just a plethora of things. I'm not going to read and go through this. This is all in your book. The main thing I wanted to give you, and I'm going to go back to some of these rack systems here, is get back. Somehow I went the opposite direction of what I wanted to do, but that's okay. We'll find it. Oh, I think it's still advancing. Okay, that's fine. I got used to some different hardware, software that we use in the lab, and I was thinking clicking on one side versus clicking on the other. Forgot I was in PowerPoint. That's okay. We can deal. So let's go back to this, and I'll probably show you some other things too. But this is a rack system in its finest, and you can see it can hold, not counting the processor. You have to have a processor. You got the power supply here, a processor here. Hold 1, 2, 3, 4, 5, 6 different cards. So we can tailor that. We can customize it. We can have a processor, a DC input, a DC output, an AC input, an AC output, and an analog in and an analog out. Or we could have all DC 3 DC inputs, 2 DC outputs, and then some kind of high-speed card over here. So again, it's what we need. It's what fits us best. So we're not just limited to a 6-rack. This is a 3-rack, obviously smaller, and this is a package controller. Now this one is non-customizable. It is what it is. It comes with a fixed amount of inputs and a fixed amount of outputs. But the nice thing is these have a small footprint. They're relatively inexpensive, and they can go just about anywhere. To show you some of the Allen Bradley stuff, I'll show you PLC systems. I'll show you. I'm familiar with Allen Bradley. I worked for them for a good bit of time, so I'm in my element a little more with that. And for some reason, my Google is slow. But let me find some of the old 1771, and then we'll show you some of this other. So let me open this in a new tab. For some reason, oh wow, always love it when the pictures come up with the same size. But you can see here a power supply, you can see a processor, and all sorts of I/O. Now what's funny, I don't know if this one's midway or if they just over-purchased I/O, or if these are some cards that don't need interface wiring, but you can see the wiring only goes to the first 2/3 probably. But that was no help, given it was about the same size as the thumbnail we had. And my apologies for this thing being so slow. I'll show you a Micrologix processor. Then I'll look at SLC, or as it's often referred, SLC. So let me open this. Another tab. Yeah. So we'll blow it up a little bit. But we've got inputs and outputs, and the nice thing about these is we can find mixed inputs and mixed outputs, and I'll see if I can find you some. I'll tell you where we can probably find some of this. Probably eBay. And if you're looking for something kind of as a hobby, eBay is a great source. Automation Direct is another. Let's just go to Micrologix here. Here we go. It's easy to find some pictures here. So there it is, and this is what I really wanted because you can see some close-ups. But you can see here, I can't move my mouse, but if you'll look, you'll see 85 to 264 volts AC. So the brick or package controller is an AC package controller as far as it's getting its power. And if you look on the right-hand side, you'll see DC inputs, relay outputs, and AC power. So AC power is referring to that input power for the processor and the package controller there. Now the inputs are DC inputs. So basically we're bringing in a DC signal. Now the nice thing is, you notice there's a, that's the output side. If you can't really see the input side, I don't know if they've got it yet. But on the input side, which is at the top, you can see there's 10 inputs, and there are 6 outputs. So again, generally you're going to see more inputs than there are outputs. The nice thing about these is they're relay outputs, which means literally to the left of bit 0 there, output/0, we can either input AC or DC, and it's a relay. Whatever you put in on the left-hand side is going to come out of the bit. So this can be a mixed module because of the relay outputs. And let's see if we can find another one that might be a different flavor here to let you see. So even with the package controllers, a lot of times we get some versatility. Here we go. Still the same value, still DC input, still relay outputs. Now that's a fairly common package, but they do come in different shape, sizes, and flavors as far as that. I was trying to find one that might be a little different there. Here's one for sure that at least has more I/O, even if it's so we've got 8 outputs, and looks like 2, 4, 6, 8, 10, 12 inputs. And this is AC power, but notice it's AC in. It's got relay outputs, and it's got some analog built into it. So again, even with these package controllers, you can find configurations, and some of these power off of DC. Not every one of them accepts AC as their power. There are DC powered modules. I'll look at one more, but otherwise you'll just have to take my word if this doesn't happen to be it. DC inputs, relay outputs, AC power. So again, that's one of the more common ones. So let's look at some SLC. And again, with these package controllers, they're going to be fixed, but you see how low cost these are. Nice thing about this, other than the software, is everything's included. Allen Bradley is very fond of their software. Now, Automation Direct is where you can buy some PLCs at a fairly low price, and the software is free. So let's see if we can find the slick rack maybe that comes with some I/O in it. We can talk about that a little bit. Yep, here we go. So you can see here, this has got 5 inputs and 5 output cards. So we've seen some with 3, we've seen some with 6, and we've now seen some with 10. And you see there's 5 outputs on the left and 5 inputs on the right. And obviously that had a special purpose, but got a good price on it, $99 if you want to get into the slick. Now that's some kind of remote rack, because if you noticed, there's one thing missing. There's no processor there, so this must be some kind of remote rack for SLC. Here's another. Here's a 7 slot. We'll see if we can hover over it. And look at it. So again, you can customize these things and make them however you want. Here's another one that's got the processor in it. We'll hover over it, and there's power supply on the left, processor, the slick 501 CPU, a couple of input cards, an analog input, a couple of slot covers, and a DCM module. So again, customizable to what you want. SLC is one of the older generations, but even older than that for Allen Bradley is the PLC 2 rack. Let's see if we can find some of that stuff. And here's some really old stuff. It was old when I started 35 years ago. Here's a populated rack system, and you can see here, this is an adapter, so this would have been a remote rack here. So no processor here. It would have been driven by a processor somewhere else, but you can see some inputs and output cards there. So those are knocking at about, goodness, probably 40 to 45 years old now, but they work as good as anything Allen Bradley ever made. So again, I'll show you some of the Automation Direct stuff, and it's some of the cheaper stuff. It's not something I would necessarily put in a shop somewhere unless it was kind of a standalone device. But their quality's got better, I think, through the years, and certainly the prices are spot on for new stuff for sure. And hopefully this page will load fairly quickly. Maybe not. Alright, this is some of the brick stuff that Automation Direct sells. Some of the package controllers are bricks, as they call them. And that's because they're not much bigger than a brick in general. So let's look at some of their direct logics, if it'll hurry up. I had paused the video. Alright, so this just shows you direct logics. They've got AC powered PLC units, DC powered PLC, 10 DC in, 8 relay out, 10 in, and various things. So you can just take a look at this and see, but all different flavors and all different configurations you can get in this I/O. So they have similar traits. The programming is similar between all of the families, but they're all a little bit different. But once you kind of learn one, it can translate fairly easily into another. So that's just a look at hardware and all the different variants out there. But pretty much you're just wiring inputs to input devices and outputs to output devices and writing code that will act upon whether that input is on or off. You may choose to say when this input's on and that input's off, turn on this output. So you determine what the PLC programming is as far as looking at and reading these inputs and acting upon these outputs. Same thing your brain does every day. If you're riding down the road and it's been kind of cool and you've had your windows down, at some point your brain may say, it's getting kind of warm in the car and must have warmed up outside, so I think I'm going to act upon these inputs. The fact that it's warm in the car, it's warm outside, I'm going to roll up my window and I'm going to turn on my air conditioner. So rolling up my window is an output. I have rolled or at least pressed the button if it's an electric window, and I have turned on my AC. So I took those two inputs and I acted on a couple of outputs. So our brains are just what CPUs and PLCs are. They are acting upon reading inputs and acting with outputs. So no different there. So when you think of it in those terms, pretty much a one-to-one translation.